Let's do the last bit of this experiment then. We're going to make a metronome. So for those musical people of you, you'll know that a metronome is something that helps you to keep the beat. Ding, 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 ding. But this is a special one because this can also tell you the bar, like and so on. So there you are. You can become rock musicians. So what we have here, first of all, is you've just got our pulses. So I've said it quite fast, so it doesn't take all day. So ding, 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 ding. That's a fast rock beat. But what we need to do is get another segment to light up on the first beat of each bar. So how do we do that? Well, we're going to use another Schmitt trigger NAND gate. And it's going to be similar to the memory circuit that we had before. It's got a capacitor on the input there. And what we're going to do now, instead of just touching a wire to +9 or ground or whatever, just to put a high charge on there or discharge, what we're going to do is we are going to slowly take away the charge of the capacitor with the pulses from our metronome pulse generator. So every time there's a low pulse, it's just going to take a bit of charge away, take a bit of charge away, take a bit of charge away. And what's eventually going to happen is that's going to be low enough for this gate to say, that's low, and then the output will go high. So what will happen will be that the capacitor will quite quickly fill up via the 56K and this diode to back up to top again. So that means then this goes low, and then repeat the whole cycle. That's what happens. Well, look, let's just see what happens in real practice. So what we're going to do is just quickly wire this up. So we need to have a 10 microfarad capacitor on another gate input. So we do that there, plug it in. So choose that input there. And we're just going to just keep the other input to 9 volts. Nothing too exciting there. So we just do that. Other input, plug in the wire, 9 volts, just like that. Lovely, lovely. And then the output is going to be going to D. So it's going to be the bottom segment there. So let's do that. So keep an eye on what it's doing. So the output is just one more in. And there you go to A, B, C, D. Just like that. And it's just stuck there high because we haven't done anything special yet. Now, what's going to happen is this. We're going to go from output back to input via 56K and a diode. A diode is to ensure the one-way action. So what we'll do is you just go from 56K, which is going to go from the output, check it's the correct output, to a spare column. And then we take a diode. Now the diode has got to point back to the input. Now this line of the diode is the black line on the diode here. It's not always clear to see, but you normally find there's a silver line or a black line more on one side of the diode. Let's try that then. So this is going to go back to the input that's got the capacitor. So you go from that same column the resistor went to, the input's got the capacitor. See what happens. All right. Now let's carry on. We've done all the front bit now. Now we need to go back from the capacitor via our variable resistor and another diode back to the pulse generator. So that's easy to do. So we'll just go from our capacitor input, which is on the second NAND gate. We just go to our variable resistor. And then we take another wire to go from the wiper of the variable resistor. And that's going to go to some spare column over here. And finally, you've just got to put in the last diode. And that's going to point towards the output of the gate. So the black line is going to be this output. So stick that in there. And you go to where that wire is to see what happens. Look at that. It's already happening. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. There you are, lovely. So that's counting 6 beats in the bar. If we set the resistor to smaller, it's going to be a bit faster still. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. And if you want to have, say, marching time, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Of course, lots of songs are slower, so we could actually put a higher value resistor than the 56K and that would slow the beat down. But let's keep things simple for now. And of course, if you want to just count a really long time, there you are. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you are. So actually, this is a very simple divider circuit. So what's happening is that the number of pulses coming out is, in this case, 9 times fewer than the number of pulses coming from here. So could be useful. Well, that's the end of that experiment, so well done.